If I look at the next one, I want to find all the zeros, and this time I'm going to have to do a little bit of guess and check using that 8. Remember, I take the factors of 8, the 1, the 2, the 4, and the 8, and then the negative versions of that as well. And I divide them by the factors of the leading coefficient, which is 1. So I'm just going to test some of these, so I might choose something like a 2, and I plug it in and see if it works. So that one doesn't work because it doesn't give me a 0, so 2 is out of the picture. So maybe I try something else. Maybe I'll try a -2 since the 2 is already there. And that one happens to work, okay? Which means this thing factors into an x plus 2 and an x squared minus 3x minus 4. So an x plus 2. This factors further into an x minus 4 and an x plus 1. And now I can set each factor equal to 0, so I find out that x equals -2, a -1, and a +4. Okay? Next one, I'm doing the same thing, so I'm looking at factors of this thing. So I might try something like a 2. Which happens to work, which means my factors are going to be an x minus 2, then an x squared minus 4x plus 5, which that's not going to factor any further. So that means that x equals 2 is one of my solutions, but now this, I've got to set this guy equal to 0, which I'm going to solve by completing the square, subtract the 5 from each side. B divided by 2 and square it gives me a 4. It's going to be an x minus 2 squared equals a -1. I take the square root of each side. So I find out that x equals 2 plus or minus I. So those are my 3 solutions. 1 real, 2 complex. Okay? Number 31, I do the same thing. I start off with some of the factors of this thing. So I might try something like a -2. 2 didn't work, so then I try something else. So it looks like a 5 seems to work, which means this factors into an x minus 5. And an x squared minus x minus 6, which factors further into an x minus 3 and an x plus 2. So then my final answer here, my x values for this one, x is going to equal the -2, +3, and a +5. This one I'm going to use Pascal's triangle. And remember, Pascal's triangle is this thing. And we can continue to create this by just adding the terms to the ones next to each other. We have to keep doing this until I get the row that is associated with the 6th power. So now I'm going to write down essentially these coefficients, the 1, the 6, the 15, the 20, the 15, the 6, and the 1. And now I put my a values down in descending order, a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, and a to the 0. And then my b values in reverse order, b to the 6th, b to the 5th, b to the 4th, b to the 3rd, b to the 2nd, b to the 1st, and b to the 0. And then all I do here is I plug in the a and the b value, which are these, the a and the b. So a is an x, b is a -2, and I just plug these in. after I have these plugged in, I'm just going to simplify this as far as I can. All right, so it gives me this. This one, we've got a polynomial function that has these x-intercepts, which means it has these factors. And it's got a y-intercept of 2, which means I need to find an a value here that may or may not exist, or might be a 1. In order to do that, I plug a 2 in for y. Essentially, this is giving me the ordered pair 0, 2, which means I plug a 2 in for y, I plug a 0 in for x, and I can solve this for a. And so when I do that, that gives me a positive 8. So I find out that a equals 1/4, which means that if I want this thing in standard form, I've got y equals 1/4 x plus 4. And now to put it in standard form, I just have to multiply this thing out. And that's it. The next one is essentially the same thing, except instead of giving this to you as zeros, I gave it to you as ordered pairs, which means you still have these factors, the x plus 5, the x plus 3, and then the other one is the x minus 3. And then from here, I'm giving you a y-intercept. Right here, this is my y-intercept, so I plug the negative 20 in for y. I plug the 0 in for x. And I just have to solve this. Let's see, that's going to be a negative 45. I divide and I find out that a equals, that's going to be a 4/9. So now if I want this in standard form once again, I'm going to plug in what I know, and I just have to multiply this thing out. And that's it. For these, we want to identify the degree by looking at the differences here. So for this one, I've got a difference of 3, and then 5, and then 7, and then 9. And now that's not a common difference, so I break it down further. So I look at the second difference. That's a 2, a 2, and a 2. And since I have a common second difference, it means this is a second degree polynomial, which means it's a quadratic. So I'm just going to plug this into my calculator to get the equation. So to do this, I go to the stat button. So I hit stat, edit. I'm going to punch this list in. It looks like I already have 1 through 5 in there, so I just have to punch these values in. Now once I have that punched in, I go to stat, I go over to calculate, and since I know it's a second degree, it means I want number 5, a quadratic regression. And it tells me basically that my equation is y equals 1x squared plus 3. Okay? I'm essentially going to do the same thing with the next one. For this one, I look at the difference here. That goes down 2, so that's a negative 2, up 2, that's a positive 2, 12, and then it looks like this is a 28. And so now I look at the second difference. Since that didn't work, that's a 4, that's a 10, and that's a 16. And that doesn't work, so I look at the third difference here. Third difference here is a 6 and a 6. So it says a third difference means this is a third degree polynomial. So once again, I go and punch it into my calculator. And then I go to stat, over to calculate. Since this is a third degree, I know I'm looking at number 6, which is a cubic regression. So I find out that y equals x cubed minus 4x squared plus 3x plus 2. That's it. Good luck on your test tomorrow.